In 7.2, we're looking to calculate area under a bell-shaped curve, that curve, we call it a normal distribution. It's a normal distribution curve. And data, whenever it resembles a bell shape, we're able to use very nice tools in statistics to calculate probability. And probability also means area under the bell shape. So we're going to look at some examples using a calculator on how to calculate probability or area under the curve. In example 1, let x be the height of a 3-year-old, where the height is normally distributed with mean 38.72 and standard deviation 3.17. Find the proportion of 3-year-olds with height less than 35. This word proportion can also mean probability, and when we're dealing with normal distribution, area under the curve. So in this example, we first begin by drawing the bell shape. And one of the properties that you saw in 7.1, whenever you have a symmetric bell curve, you're centered around the mean. Okay, the mean in this problem is 38.72. And we'll make a note of the spread. Here the spread says 3.17. So sigma is equal to 3.17. Now, notice what the problem is asking for. It's asking for us to find the proportion or probability of 3-year-olds with height less than 35. So I want you to treat this horizontal axis, treat it like a number line, okay? And that number line is centered around 38.72. I want to place 35 on that number line as well. And notice 35 would have to go somewhere on this side here. And if I'm looking to be less than 35, I need to shade this way. Okay. So in 7.1, 7.1 says if the entire bell curve is shaded, your probability or area is 100%. If only half of the bell curve was shaded, your probability is 50%. Okay. But notice I only shaded a piece of it, right? A piece of that half. So this area right here, we should expect it to be less than 50%. So how do we calculate that probability? So the notation, probability that x is less than 35. When you're dealing with area under a normal bell curve, the tool that we use is called normal CDF. Okay. So with the TI-83 or 84, let me show you where to find it. So turning on the calculator, okay, you'll go to second and then vars. That's going to pull up your distributions, your different distributions. And I want you to go to number 2. Okay, number 2 says normal CDF. Now, if you have the TI-83, it doesn't really tell us what to put in for the arguments. The TI-84 does, okay, but I want to show you with the 83 as well what it looks like. So you need 4 entries, okay, you need 4 things. The first thing you need is the lower bound. What that means is how far low on the number line does the shaded region go, okay? The next argument we need is the upper bound. How high up on the number line does the shaded region go? Then we need the mean of the problem and the standard deviation. Those are the 4 entries that we need in order to calculate that area under the curve. So in 7.1, one of the properties of the bell curve says the tail never touches the axis. So if that's true, that means that the shaded region keeps going and it doesn't stop. And if it doesn't stop, then where is the lower bound going to? So we have normal CDF. The lower bound, because it's not stopping, it's going to negative infinity. Okay. So here, I'll place negative infinity for now. I'll show you how we deal with that in a bit. The upper bound, it wants to know how high on the number line did we go. Well, here it does go to a finite number. It stops somewhere, 35. That's the upper bound. The mean of the problem is 38.72, and then the spread is 3.17. Okay. Now, in the calculator, there is a problem. We don't actually have an infinity symbol. The way we remedy the infinity symbol is if you look at the 7, go one button up, that's your comma button. If you hit second and then E like that, that's going to produce an exponential notation or a scientific notation where E99 for us will represent infinity, negative E99 will represent negative infinity. Okay, so because we do need a negative infinity, we'll go back here and type in negative, and then E99, okay, that's going to represent the negative infinity. So we should have this in the calculator. Normal CDF, nega E99, upper bound was 35, the mean 38.72, and the spread 3.17. So let's go ahead and fill in. So in the TI-83, you do need the comma in between each, 35, comma, 38.72, comma, and then 3.17. Okay, so that's going to find how much of this bell curve was shaded. Okay, once again, if the entire thing was shaded, we should expect 100%. If half of the shape was shaded, it'd be 50%. This is just a little piece of the half, so we should be less than 50%. So here we shaded about 12% of the curve. So here, the probability that the height is less than 35 inches tall, okay, when the average height is 38.72, the probability of selecting an individual with height less than 35 inches tall is 0.1203. In the TI-84, it's very similar. So let me load up the TI-84 for those of you who have it. So let's open, okay. So for those of you who have the 84, this is what you'll do here. So you'll still go to the second vars, okay. You'll still go to normal CDF, and your normal CDF window actually does give you the arguments that you need. So we said the lower bound was negative E99. The calculator defaults to negative 1 E99. That's perfectly fine as well. That's also a negative infinity. Just to be consistent, let's keep it at negative E99. Okay. The upper bound was 35. The mean, 38.72. And then the standard deviation was 3.17. So when you paste, it'll place it in the home screen, and then we'll also get that 1202, 1203 answer.